everyone, so welcome to our second day of graphing quadratics. Now today we're just gonna pretty much learn a way to make our graphs more accurate, more precise. I heard students say make it look more pretty, which pretty much means more accurate. Now I do have to give you a forewarning, this video is going to be pretty long, but 80% of it is just review. So I'm going to go kind of quick with finding the y-intercept, the axis symmetry, the vertex. And the main reason is because there's past videos of where we concentrated on this. There's even a practice. So my hope is that you guys understand how to find those parts of a parabola. And then I'm going to zone in a little bit more on what we're adding today, which are the zeros of the graphs of parabolas. Now, I know this is a little bit mixed up. So the first thing I want you to do is to write down this definition down here of what are zeros. Now, zeros sound pretty complicated, but they're not. Zeros of a quadratic equation are the x-intercepts of their graphs. That's literally all they are. So what we're going to do today is pretty much concentrate on not only finding the prior information that we did, what we're going to do is also find the x-intercepts, where the graphs cross the x-axis. So write that down, have it somewhere in your paper, so if you hear me say zero, you know exactly what I'm talking about, which again is just the x-intercepts of parabolas. So let's just start with this entry task, which 90% of it is just review. Remember that whenever you're graphing a quadratic, which we have in front of us, the first step you want to do is to find your a, your b, and your c. Your a is always going to be the coefficient of your x squared term, which in this situation is a 1. Your b is going to be a positive 6, and then your c is going to be the constant, which is an 8. Remember that these don't change. Your a is always a coefficient of the x squared, your b is always a coefficient of the x, and your c is always a constant. Now that we have our a, b, and our c, we know whether it's facing up or down. We know it's facing up or down just by looking at the a. If the a is positive, you know you're going to have that u, or that parabola, facing upwards. So just by knowing that, there's a lot of information that I know already. Let's go ahead and be more precise by finding the axis of symmetry. Now, the hardest thing about finding the axis of symmetry, and just a quick reminder, the axis of symmetry, when you have a parabola, is that vertical line that goes up and down that cuts the parabola perfectly in half and makes the left side symmetric with the right. It is quite easy to find that axis symmetry. The hardest part is just remembering what the formula is, and the formula is a negative b divided by 2a. So once you find your a, b, and your c, just plug it into your axis of symmetry formula in order to find where it's at. So a negative b, my b is a positive 6, my a is a positive 1. A negative times a positive is a negative 6, divided by 2 times 1, which is 2. Negative 6 divided by 2 is a negative 3, so that means that x is equal to a negative 3. If I go to my left of my graph over here, this is my x-axis. Here is negative 3. The axis of symmetry is going to be that vertical line represented by x equals 3. Now, again, the hardest part is just remembering the formula, so make sure you have it down so that way you don't forget. All right, so now after that, there's a cool thing about the axis of symmetry and the vertex. Remember, the vertex is the lowest point or the highest point of a parabola. In this situation, it's going to be the lowest because our parabola is facing upwards. But keep in mind that the axis of symmetry and the vertex intersect, so that means that that point, the vertex, the highest or lowest point, share the same x values. So if my axis symmetry is a negative 3, the x value of my vertex is negative 3. Now, unfortunately for us, finding the y value of the vertex is not as easy. But if you have strong algebra 1 skills, you should be fine, because all you have to do is remember, you know that y is equal to x squared plus 6 times whatever x is plus 8. You know what your x value is. It's your job to find its y value. So just plug it in. Y is going to equal whatever x is squared plus 6 times whatever x is plus 8. Again, I'm plugging in a negative 3. Now it's my job to solve it. Do not forget your order to do math, which is memorized by PEMDAS. Notice that there's no work to be done inside of these parentheses, so let's go ahead and do some exponent work. 3 squared is a positive 9. Notice that I do a step and I rewrite my equation. So there's no parentheses, we just finished the exponent. Let's do some multiplication, which can be found in those parentheses. Y is going to equal a positive 9 minus 18 plus 8. No more multiplication, no more division, we just got a bunch of addition and subtraction. I like to just do my addition and subtraction from left to right. 9 minus 18 is a negative 9. And then plus the 8, you end up with a negative 1. So you have now found the y value to your vertex. You already had the x because again it shares the same x value of your axis of symmetry. All you got to do now is plot it, which is what I did exactly right there. All right, so notice that I have my vertex. I have my axis of symmetry. I know it's facing upwards. I could randomly draw my graph somewhere going up, but again, I'm trying to make it look pretty. So let's find the y-intercept. It's actually quite easy to find the y-intercept because you know if you ever have a y-intercept, your x is always 0 and the y value is always going to be your c. So you know the point is 0, 8. 0 and 8 is 1, 2, 3, 4, 5, 6, 7, 8 right over here. Notice it's 3 units away to the right, so I'm going to go 3 units to the left of that axis of symmetry. Now, so far, I had you guys, that's about as far as I wanted you to be accurate. You were able to draw your graph. But again, I want you to find the zeros. Now, if you forgot what the zeros are, remember that it's just the x-intercepts of the graph. Now, how in the world are we going to find the x-intercepts? Let me change colors so that way you can see. Haven't used purple yet. Let's go with purple. Okay. So remember, zeros are just the x-intercepts. Now, if you remember, if you ever have an x-intercept, what does your y always equal? And your y is always going to equal 0. So what we're looking for is what values of x make my y 0. Now, your original equation is y is equal to x squared plus 6x plus 8. Again, what are you doing? You're looking for the x values that make your y 0. So what am I going to do? I'm going to place that y with 0 and solve for the x values. Now, most of you guys are like, hey, that looks really familiar. We spent all the first half of this unit solving quadratics by solving by factoring, solving by quadratic formula, etc., etc. Now, this is where you guys are taking those math skills and just reapplying it in order to make your graph prettier or to make it more accurate, more precise. Now, I always like using the quadratic formula. If you don't remember it, it's x is equal to a negative b plus or minus the square root of b squared minus 4ac all over 2a. In order to do that, I need to recognize my a, b, and my c, which is what I did above anyway. And I just go ahead and plug everything away. So x is equal to a negative b plus or minus the square root of b squared minus 4ac. I was writing my variables when I should have wrote my parentheses. All divided by 2 times a. Now let's just fill in the pieces. A negative b, my b was a 6, my a is a 1, and my c is a positive 8. All divided by 2 times a, which in this situation is a 1, still a 1, my a is. Now I'll go ahead and you have to solve for this. A negative times a positive, negative times positive is a negative 6, plus or minus the square root of all that garbage divided by 2 times 1, which is 2. Now, remember to put this in your calculator exactly the way it is so that way you don't make mistakes. In this situation, I'm going to go ahead and do that. So parentheses 6 squared minus 4 times a, which is 1, times my c, which is 8, and I got a positive 4. So I notice I have a positive 4, so I know I could actually, it's nice for me because I could take the square root of 4, which is what times itself equals 4, which is 2, all divided by 2. Notice I have two equations, which I'm going to continue over here. I have negative 6 plus 2 divided by 2, negative 6 minus 2 divided by 2. And let's go ahead and figure this out. Negative 6 plus 2 is a negative 4 divided by 2, and that simplifies to a negative 2. So that is one of my x-intercepts. Let's go ahead and do the other one. So negative 6 minus 2 is a negative 8 divided by 2 equals a negative 4. So there I go. I know that my other x-intercept is a negative 4. Now all I have to do is plot them. Negative 2 is right over there. Negative 4 is right over there. So I know you can't see it with that line. Let me make it a little bit cleaner so that way you can see it a little better. So again, negative 2 and 0 can be located here. Negative 4 and 0 can be located there. So notice that now I have all my points plotted. It's actually should be easier to draw my graph. So review. This is the difference. So notice I left zeros and roots. The good thing is that roots are literally just a solution to quadratic formulas. So notice that when I set it equal to 0, I technically have a quadratic equation. The solution are called roots. When you graph them, those are called zeros. Now, I'm not sure why the distinguishing is other than you're dealing with equations in one and the other one you're graphing. So again, roots and zeros are one and the same for the most part, but roots are solutions, I guess, to whatever you set it. If I were to set it to something else, or if I had another quadratic, that's where the difference is. But for the most part, for our situation, zeros and roots are going to be the same. Now, that is pretty much, as you notice, a pretty lengthy process, but it's all kind of, it's not hard math. You just got to make sure you got the process down and got your process and know where you struggle to make sure that you got it down. So again, zeros and roots are solutions to quadratic equations. Zeros are the graphs or the x-intercepts. So for our case, they're going to be the same, at least for this class. Now, let's start talking about a little bit what could happen here. So if I'm telling you to find the zeros, I'm telling you to find the x-intercepts. Now, there are three situations that can happen. You could graph, and it depends whether it's going up or down, doesn't matter, that your quadratic is going to cross twice. Now, if your quadratic crosses twice and you try to solve the quadratic equation, you should get two real solutions. Why is that? Because you have two x-intercepts. How do we know, or what's a shortcut? Well, that means that our discriminant has to be greater than 0. Now let's say we are graphing our equation and I only end up with one x-intercept or with one root. Well, that means I'm going to have one real solution or one x-intercept. That means that my discriminant was equal to 0. Now what if I have 0? Well, that means that you're graphing something that never crosses the x-intercept. That means that you have complex solutions, but in terms of the graph, it shows up because you don't have any solutions. You're in the imaginary world, and we're only in a real world situation. So that is when your determinant is less than 0. So you can notice here that you can actually skip a little steps in terms of finding the x-intercepts if you know, or using the quadratic formula if you know a little bit about how the graphs relate. And again, they're pretty straightforward. Solutions, again, are the x-intercepts. So if you have 0, 1, or 2, you should know. So these are just two additional examples just to make sure that we got it down. Now, I know this is a lengthy video, but you can always try them on your own. Fast forward to see if you got them right, and then make sure you understand the additional part. So I'm going to go kind of quick, so that way for video's time's sake. So again, I have a quadratic. I know my a, my b, my c is the first thing I should be looking for. My a is always the coefficient in front of the x squared. My b is going to be the -6 because it's in front of my x, -6. And then my c is going to be the constant. Now, I know that my y-intercept is always going to have an x value of 0 and a y value of c, which in this situation is a 9. My axis of symmetry is going to be that magical formula of -b divided by 2a. So a negative, whatever b is, divided by 2 times a. My b is a -6. My a is a +1. A negative times a negative is a +6. And then 2 times 1 is 2. Finally, finishing up the math, I end up with 6 divided by 2, which is 3. All right. Now, what I like to do is find one thing and then go ahead and or graph it actually. Because again, our goal is to graph. We're doing all this work in order to graph. So my y-intercept, 0, 9 is right over here. My axis symmetry is where x equals 3, which is right over there. And draw it as straight as possible. And now I'm going to find my vertex, which is, in this situation, 3. I don't know what the y is yet, but I'm going to use my equation to solve it. So y is going to be equal to whatever x is squared minus 6 times whatever x is plus 9. Again, I'm plugging in a 3. There are no work to be done in the parentheses, so I'm going to start with the exponent. 3 squared is 9. Multiply just to save some time, which is -18 plus 9. 9 minus 18 is a -9 plus 9. I end up with 0. Now that might seem a little bit weird, but that's okay because that is my vertex. It's okay. -3, 0 falls right on that line. Now let's think about this here. I know that this is the vertex. I know that this graph is facing up. So this is the lowest point. No matter what, if this is the lowest point, it has to go up. Let me draw this a little bit better. I forgot about my symmetry. I know that this is 1, 2, 3 away, so it's going to be 1, 2, 3 the other way. So I know that it has to be facing up. Now, if that is the lowest point of a parabola, there's no way it's going to cross more than one. So there's no need to find my zeros or my roots because I'm only going to end up with one solution. You'll notice that what happens is if you were to find your discriminant, you would end up with your discriminant equal to 0. You're only going to have one solution. So this is a very, very common thing. I could have skipped steps and understood that just by looking at that, I only have one x-intercept because, again, my vertex falls on the x-axis. Now, that's one thing. Let's go ahead and see another example, which I think you can know. The first example was 2 solutions. The next one was 1. Let's see what happens when you have 0 solutions. All right, so, okay, so here is my quadratic equation. I know my a is 2, my b is 4, and my c is also 4. In order to find my y-intercept, my x is always going to equal 0, and my y is always going to be equal to my c, which is 4. So I know that this graph is going to cross at 0 and 4. 1, 2, 3, 4. Now let me find my axis of symmetry. It's located by a negative b divided by 2a. So x is going to be equal to a negative whatever b is divided by 2 times a. Your b is 4. Your a is 2. Negative times 4 is negative 4. 2 times 2 is 4. Negative 4 divided by 4 is a negative 1. So x equals a negative 1. Let me make sure I'm not confuse you with that negative there. Negative 1. So double checking to make sure I got this right. I did. My x equals negative 1. I know that this is my x-axis. Negative 1 is there, and I know that this is going to be my axis of symmetry. Now let's go ahead and find our vertex, which is just the highest or the lowest point. My x is negative 1. In order to find the y, all I have to do is plug it in. So y is going to be equal to 2 times whatever x is squared plus 4 times whatever x is plus 4. Again, what am I doing? Plugging in a negative 1. Remember your rules of PEMDAS. Start with the work inside the parentheses, which never is going to be some. Let's start with the exponents, which is negative 1 squared. Negative 1 squared is a positive 1. Now let me go ahead and do all the multiplication, which is 2 times 1 and 4 times negative 1. End up with 2 minus 4 plus 4. Negative 4 plus 4 cancel out. You're left with a positive 2. So your vertex is negative 1 and 2. Negative 1 and 2 is located 1 and 2 right there. So again, this is where your analyzing is going to have to come into play of how these graphs react, because zeros are x-intercepts. Roots are the solutions to a quadratic. Now, I know this is a parabola that's facing up because my a is a positive 1. Now, I found my lowest point, which is here. It has to go up. So let me draw accurately to the right here. It has to go up. You know it has to go up because it's facing up, and if that's your lowest point, it got to go up from there. Now, is there a point in terms of finding my zeros? No, because there are no zeros. This is the x-axis. Zeros are just where your graph intersects the x-intercept. So what you want to say there is no x-intercepts. Now, should we go ahead and find the discriminant? Not really, because the graph shows us enough information that we don't have one. So that's pretty much it. Notice that your homework is going to have a lot of this practice. Try to get the routines down. I think the biggest thing that I could kind of hope to reiterate here is understanding that you're going to have some x-intercepts. You're not going to have some x-intercepts and some solutions. And it all depends on what your graph starts to look like. For instance, if you have a graph here, and you don't have to write this, by the way, don't include this in your notes. If you want to shut me off, shut me off. This is just to try to reiterate the important things. If you end up with a graph that ends up with a y-intercept somewhere here and a vertex somewhere down here, and of course your a has to be positive, of course it's going to face up, of course it's going to cross the x-axis twice. That should tell you, hey, I guess I have to find the zeros. So I have to set it equal to 0. I have to find the roots to figure out what those values are. Now you are going to get to situations where things get a little bit easier. Let's say you find the vertex and it's exactly on the x-intercept. Now your vertex is the highest or lowest point. So that means that that is the only time if your vertex ever hits the x-axis, those are your x-intercepts. You don't have to you don't have to set it up to 0 and solve for them, or using the quadratic formula like I did in the first example. And you're going to get situations where you have a vertex somewhere like this and a y-intercept up here, and you know your graph goes up. So there's no need, because there's no there's no x-intercepts there. The only ones you have to is if you start drawing your graph and you end up with a situation where it's visually obvious that you're going to have those x-intercepts. So that's pretty much it. Hopefully this video didn't go too long. We're just adding that little bit of piece to our graphs.